you can say it. No. All right, here we go. So today what we're going to do is we're going to look at, begin our chapter 2. In 2a, we're going to look at what are called factors and multiples. And we've actually worked with one of those before. We've worked with multiples, haven't we? When we were doing long division, do you remember writing out all of those numbers? 1 times 43, 2 times 43, etc.? We were actually finding multiples of those. We've also defined factors a little bit too, but we're going to talk about a little more formally today. So the first thing we want to do is we want to define a factor. Now there are a couple of things about factors that you need to know. And it's really important that you understand about how factors work, because you're going to be building on this idea all through your algebra career. There's a lot of work with factors in algebra. We're also going to be looking at fractions pretty soon, and when you're dealing with fractions, if you don't know what factors are, then fractions can be very difficult. Okay? So keep in mind what we're doing with the factors. A factor is any number that will divide evenly into another number. Now, they have another definition, and that definition is based on multiplication. But when you're finding factors, we generally find them by using division. So the division definition is better here, because when you use factor as a verb, what's a verb mean? So yeah, they're a doing word. It's an action word. Or you're using factor as a noun. So what's a noun? So like a name kind of thing, right? Then that's two different things. So factor as a verb, you're using division. Factor as a noun, that means that you're collecting them with multiplication. So it's a slightly different, right? You're used to that two words being able to be used in different ways. Now, the first thing we're going to talk about factors is there is one very special factor, and that is the number 1. The number 1 is a factor of every number. So, guys, they need to mute if the dog is okay. I'm easily confused by dogs barking. All right. So, in other words, 1, every single number will divide by 1. Do we agree? Yes. Okay. So 1 is a factor of every number. Okay. Second thing. The largest factor, guys, come on, of any number is the number itself. So the largest factor of any number is the number itself. Okay? Another thing about factors is factors are always in pairs. What does a pair mean? Right, so there'll be 2 of them, you betcha. Okay? And they are always connected by multiplication. We find them by using division, but they're always connected by multiplication. Yes?
When it says the largest factor of any number is itself.
So keep in mind, this never goes away. to list every factor of a number. So it doesn't matter what the number is. We'll look at several examples. But to list every factor of a number, the first step is to start with 1. And remember, they're always in pairs. 1 and the number itself. Remember, the hashtag is the abbreviation for number. So you always start with 1 and the number itself. So the first thing you get is the smallest factor and the largest factor of every number right off the beginning, from the very beginning. And there's no division there. It's always, divide any number by 1, you get the same number you started with. Second, try 2. See if 2 will go into it. Now, we know that 2 will only divide into what kinds of numbers? What are they? Even numbers. There you go. Yeah, if I don't call anybody, just sing out. Okay, perfect. Then, try 3, etc. What I'm trying to get you to see here is that I'm trying numbers in numerical order. Don't just jump around. We know that 8 divides into 24, right? But we don't want to start with 8. We want to start with 1, then we want to start with 2, then we want to try 3, etc. And again, remember, they always come in pairs. So we're going to list them as pairs. All right? 4. Continue to test numbers until you get a number that is already on your list. So continue to test numbers until you get a number that's already on your list. Once you find them, they're all in pairs. Then we want to write in a list. And I'm going to write this down, and then we'll talk about what it means. With no repetition. You never repeat a number, even though it may be on your list more than one time, in the original list. For example, if I was writing the factors of 4, 1 goes into 4 how many times? 4 times. 2 goes into 4 how many times? Twice. So 2 is a factor of 4. But we would only write it one time on our list. Even though when we write out when we're doing the factors, they come in pairs. If it's the same number, you only write it one time. Okay? So you would never repeat that. Can anybody think of why of what kinds of numbers that's going to happen for? What are they called when you get the same number times itself?
Prime.
Well, not prime, but there's another one. There you go. It was a perfect square. Right, there you go. Yeah. Now, prime is another one, though. What happens with prime numbers? They're only divisible by what? 1 and the number itself. Right. So prime numbers are only going to have 2 factors, and we're going to spend a good deal of time talking about prime numbers. But if you get the same number times itself, that means you started with a square, right? And then, but if you only have 2 factors, that means you've got a prime. Good. All right. So we're going to just go through and demonstrate this really quickly. So you've got your notes on one side here, but let's do an example. Say, for example, we want to list every factor of 24 for somebody out there. I don't know who. All right, here we go. So, think about what we need to do. Think about our directions there. Okay. So Lachlan, are you out there? Lachlan? So I always start with what number, please? Are you out there, Lachlan? Okay, no worries. Sam. Sam F. Yes, Sam. I always start with what number, please?
1.
And 1 goes into 24 how many times? 24 times, exactly. The first pair of factors is always 1 and the number itself. Good job, thank you. Will N. Can you tell me then, what number will I try next? 2. Will 2 go into 24? How many times, please? 12 times. So do you see what I'm doing? I'm writing them as pairs. When you're finding the factors, write them down as pairs first. Excuse me. George Barnes, where are you?
Yep.
There, George. Will 3 go into 24?
No. Oh, yeah.
How many times?
8.
There you go. Okay, 3 goes into it 8 times. All right, no worries. All right. Finley, you're out there somewhere on the... Yep.
Get them to speak,
Well, they're usually very vocal. Okay.
Finley, I think you did Paul.
All right. Thomas.
So can I put next?
Oh, who is that?
Nicholas.
Oh, okay. How do you know that? We'll get there. Thomas. Okay, Thomas. Next number after 3 is 4. Will 4 go into 24?
Yes.
How many times?
6.
6 times. Good. Leo, after 4, what's the next number after 4? Sorry. 5. But will 5 go into 24? No, so it doesn't go on our list, right? Okay, good job. Ryan, so then the next number after 5 is 6. Will 6 go into 24? Yes, but look at my list and tell me, why do I not need to write down 6?
Because it's already a 6.
6 is already on my list, exactly. That's how you know when to stop. All right? Once you get to a number that's already on your list, or bigger than one that's already on your list in some strange cases, then that's how you know to stop. You know you've listed every single factor in that case. So now what I'm going to do is make a list. So here we go. So my list, remember, a list is just a list of just the numbers separated by commas with no repetition. So 1, 2, 3, 4, and then I'm going to go up here. Because remember, when you're listing numbers, you should always put them in numerical order. 6, 8, 12, and 24. And that is the answer for your list of factors. This is your working. That's how you got them, and I want to see that. But your answer is this list of factors. Yes, sir.
If it was like a smaller number, like 24 or like 12, could you list out all the numbers counting up to 24 and then just like figure out which one's
Yeah, but you would be going on beyond what you need. So it's best just to do a 1, then try 2, then try 3, then try 4, etc. Okay? All right, let's look at another example. 6, okay? Yeah, no, 6 is a good one. That's exactly what kind of thing I was hoping for. All right, look at what we're doing. So, all right. Jonathan,
Yes.
first thing I do is I'm going to try what number always first? 1. And 1 goes into 6 how many times? 6 times. It's always 1 in the number itself. Good. Will R. He's online. Will, are you out there? Okay. What's the next number I should try then? 2. And 2 goes into 6 how many times, please? 3 times. Excellent. Okay. Joshua H. Joshua, what's the next number after 2?
3.
3. But in this case, do I need to try 3?
No, not really.
Why? And I won't try it because it's already on my list, right? So that if you go in numerical order, you always know where to stop. Okay? All right? Shh, guys. Jeffrey.
Yep.
All right, Jeffrey, make my list for me then. What is my list of factors for 6?
1,
Comma. 2, comma, 3, comma, 6. Good. So 6 has exactly 4 factors. So, okay. And it never changes from there. It doesn't matter how big or how small the number gets. The process is always the same. Yes, sir. We've listed factors. So now let's start. We need to move on and start with multiples. You'll do lots of them because your homework has lots of them in there. Okay? Shh, guys. So next thing we want to talk about is we want to talk about multiples. Now, a multiple of a number is simply any number that is made from multiplying by a given number. Now write that down, and then we need to talk a little bit about what I'm saying here. So, in other words, if you're finding multiples, that just means you're multiplying times numbers. So, for example, multiples of 10. 1 times 10 is 10. 2 times 10 is 20. 3 times 10 is 20. Okay, so you're just multiplying over and over and over. All of those numbers that you get when you multiply are called multiples. Now, guys, with factors, there are a limited number of factors for every number. But multiples are infinite. They go on forever. So, for example, if I want multiples of 10, we just did. 1 times 10 is 10. 10 times 2 is what?
20.
10 times 3 is? 10 times 4 is? And I can do that forever, infinitely. 10 times 1,573,000, for example. Who cares? You can multiply them infinitely. And so remember, that's what those 3 dots mean. Those 3 dots are the ellipsis. It means it continues in that same exact pattern forever. Okay? Right? What if I found multiples of 20? 20 times 1 is 20. 20 times 2 is 40. 20 times 3 is 60. 60, be careful. And what do you know? They go on what? Forever. Okay? Shh. All right? So, factors have a start and a finish. Multiples have a beginning, and it's always the number itself, right? Because it's 1 times the number. But they never end. Okay? So they never stop. And so those are what are called multiples. Now, it's really important that you understand the difference because you're going to be asked to find the multiples of a number and its factors. So that's 2 different operations, but you can be using the same number to do that. So make sure you know which is which. We can also find what are called common multiples. Now, if something is common, that means if you have something in common with somebody, that means you like the same thing or you have the same thing, right? What's something common about every single one of you in this class?
We're all boys.
There you go. Anything else? What color is your shirt? What color is everybody else's shirt in this room except mine? Gray, exactly. So do you see? So you know what common means. So if something is guys, so if something is a common multiple, that means it's the same multiple. There's really no other way to describe it. It's just that simple. So let's look at the list that we have on our of multiples of 10 and multiples of 20. What do you see about that list that is the same? 20 is on both lists, isn't it?
Yes.
What else?
40.
40 is on both lists, isn't it?
60 would be on both.
60 would be on both lists if we'd taken the 10 out. So do you see that 10 and 20 have some common multiples? Okay? So you can have common multiples. So what we're going to do is, let's just pull two other numbers, and we're going to find their common multiples. Okay? So let's see. Say, for example, we have the number 7. 7 is good because what's special about 7? It's prime. There you go. So 7 times 1 is 7. Times 2 is 14. Then 21. Then 28. 35. And they go on forever, right? Okay. Let's say we want the common multiples of 5. 5 times 1 is 5, then 10, then 15, then 20, then 25, then 30, then 35, and they go on forever, yes? Okay? Now, if I asked you to find on this list the common multiple, what is the only common multiple that they have? 35. Yeah. So look how far we had to go on both lists before we found a common multiple. Now, in this case, what are the factors of 35 that you see here? 7 times 5, right? And that is a pattern. Okay. So in this case, 7 and 5, the first common multiple for 7 and 5 was found by multiplying them together. Why is 7 and 5 like that, do you think?
Because they're both odd numbers.
Well, not odd numbers, but something else you said earlier. They're both prime numbers. So anytime you have prime numbers, the smallest multiple they're going to have is multiplying the two numbers together. Now, that's not true of numbers that aren't prime, though. So say, for example, we'll just do a really super easy one. So say we have 2 and 4. That's a good one. So 2 is 2, then 4, then 6, then 8, then 10, then 12, and etc., right? 4 is 4 and 8, then 12, then 16, and then they go on forever. So 2 and 4 have lots of common factors. Don't they? As a matter of fact, every factor of 4 is also a factor of 2. A multiple of 2. I'm sorry, not factor, but multiples of 2. And the reason for that is 2 is a factor of 4. So that always happens. So for example, if you had 3 and 9, 3 will divide evenly into 9, yes? Therefore, every multiple of 9 will also be a multiple of 3. See the pattern? Okay?
Yeah.
All right. So there you go. So we've talked about factors and how to find them. We've talked about multiples and how to find them. And then we've introduced that idea of common multiple. So now what we're going to do is we're going to stop now, and then we're going to go to the book and do some exercises. But I want you to think about each one of those. It's important to know which one's which. They're easy to find mathematically, but it's really important. Your job is to know which one is which, because next time we meet, what we're going to do is we're going to start using them to do some mathematics.